everyone, and thanks for joining us tonight for our public address. Let's stand and ask God's blessing on our meeting. Our loving and gracious Father, we're very thankful for the time that we have now to come together tonight to think about the things of what you've got planned with this world, with the things that are contained in your word, the Bible. We pray that you'll help us to benefit from the things we hear tonight, that you'll be with Jimmy and help him to lead our thoughts to come to reconfirm in our minds the truth of the gospel and the plan that you have with this world. So we ask that you'll watch over us in all things we do, and it's in Jesus Christ's name we pray. Amen. So Jimmy's so keen to speak to us that he even said, don't worry about a reading, he just wants to get up here and talk. So his subject tonight, as you can see from the screen, is does science contradict the Bible? Thank you.
Good evening, everybody. It's a big question, isn't it? Does science contradict the Bible? And it's quite an interesting question as well. Science is, after all, one of the core STEM subjects taught to our children at school: science, technology, English and maths. And many Christadelphians indeed teach science at school. And science-based companies also make up a large portion of Adelaide's industry. And here in Adelaide, we obviously have a large science community based around health, and I understand we also have Australia's Space Discovery Centre as well. Christadelphians also work in many science-based industries. And science is clearly an important part of our lives and of society, isn't it? And it makes the question even more intriguing, doesn't it? Does science contradict the Bible? Or I suppose the question also is, does the Bible agree with science? So to start our evening, I thought we should just briefly define science and the Bible. The Bible is quite easy to define. Simply put, it is a book written by men who were inspired by God. It is God's message to the human race. It covers over 6,000 years of history and tells us of God's plan for the future of the earth. The first written words were approximately 4,000 years ago, and its last words were written approximately 2,000 years ago. And in terms of science, as we said, it's an important part of our society, but what actually is science? Well, science is broken up into many areas, isn't it? I don't expect you to be able to read the boxes on the screen, but hopefully you can see that there are indeed many boxes. And this is one person's representation of the different areas of science. And I remember at school, when you get to age 16, year 12 in New Zealand, and science is split into 3 subjects. You can choose physics, biology, or chemistry, or all of them. And these are kind of the 3 main areas of science, aren't there? But of course, as you can see from the boxes on the board, there are many more areas. And science comes from the Latin word scientia, meaning knowledge. And when looking up some definitions of science, I found these few that I've got on the screen. The Oxford Dictionary defines science as knowledge about the structure and behaviour of the natural and physical world, based on facts that you can prove, for example, by experimentation or experiments. And then the second definition by Britannica defines science as any stem of knowledge that is concerned with the physical world and its phenomena, and that entails unbiased observations and systematic experimentation. And it's easy to note the common words used in these definitions. It is knowledge about the world which is based on facts that are observed and proven in experiments. And other definitions list science as a system of acquiring knowledge based on scientific process or method in order to organise a body of knowledge gained through research. And what this is saying is that you start with a body of knowledge, you observe it and do some experiments with it in order to gain more knowledge. And it's mentioned in that definition there, it's got there the scientific process or method. And this process is essentially these 3 steps, but if we break it down, we can break it down into 5. The first one, you have to pose a question or a hypothesis. And here you have your body of knowledge, but you want to know more, or you might want to replicate something that you're seeing to find out how it works. So for example, as a kid, you might be making paper planes with your friends out of coloured paper, and you may wonder if the colour of the paper affects the distance that the plane flies. And this is a hypothesis. You might have your hypothesis as, does the colour of the paper plane affect the distance that it flies? And so the second step, you then design the experiment. And here you decide how you're going to try to solve your question. How are you going to test which colour paper flies the furthest? So you might make 50 blue, yellow, green and red planes using the exact same design, and then throw them in a confined, peaceful hall, like the ecclesial hall here, and see how it goes. And so the third step, you then do that experiment and you throw those 200 planes and observe to see what happens. And then the fourth step is to analyse the results. And this is where you consider the results, and you might do some statistics. You might do a pie graph or a bar graph and make it all colourful and look pretty, so that you can come to your fourth step, which is to analyse the results. To draw the conclusions. Step number 5. You look at your analysis that you've done and you draw your conclusions. And a good characteristic about this process is that if it's followed correctly and accurately, then others should be able to follow the same 5 steps as you to produce similar conclusions. So these 5 steps, a question, experimentation and observation, analysis and a conclusion, it's really what defines science, isn't it? And these steps can be followed whether the science is biology, physics or chemistry. And these 5 steps is what increases the knowledge of the scientists and the knowledge of society. So having established this definition, I propose to you that science, as defined by that definition, actually does agree with the Bible. And the Bible is obviously not a scientific book, but we propose that the Bible is written by God, the creator of the earth, who is the ultimate scientist. And therefore, in the occurrences where science and the Bible intersect, they do actually agree. So I just want to display this to you using 5 examples. So the first example we have is in Job 26, verse 7. Speaking of God, Job writes, "He stretches out the northern sky over empty space, suspending the earth upon nothing." And this is really an elegant description of the earth being suspended in space, isn't it? Other translations write, "He suspended the earth on empty space." Science has actually given a name to this empty space in which the earth is suspended. Astronomers call it dark matter, which they define as matter that does not interact with the electromagnetic force, which is light. This means, of course, you can't actually see dark matter even if you shone a big bright light on it. Astronomers can only infer dark matter by the way it interacts with other things. So here, way back in Job, we have science and the Bible agreeing, as displayed in the description of the earth being suspended in space, which we know is to be true. We have another example in Isaiah 40, verse 22. Again, speaking of God, Isaiah writes, "It is he that sits above the circle of the earth, and its inhabitants are like grasshoppers." So here again, we have the Bible agreeing with the well-known scientific fact that the earth is indeed round. And you have to wonder, did Isaiah know that the earth was round before he was inspired by God to write this verse? And we don't know. Isaiah lived in the 8th century BC. The first documented mention of the concept, apart from being in the Bible, was written by the Greeks in the 5th century BC, 300 years after Isaiah. We have a third example, which is in Job 38, verse 33. I find this one quite interesting. Here we have God speaking to Job, and God is talking about the constellations that track across the sky. And in verse 33, God asks, "Do you know the laws governing the heavens, or can you impose their authority on the earth?" And this theme is picked up in Jeremiah 33, verse 25, where God says, "Just as surely as I have established my covenant regarding the day and night, the laws of heaven and earth, in the same way I will never reject the descendants of Abraham." So you can see the repeated ideas in these two verses. The idea that there are certain laws that govern how the universe works. Some of these laws humans have discovered, like the famous E equals mc squared. There is a fundamental principle of science, isn't it? Scientists throughout the ages have used the scientific method to prove existence of laws and to discover new ones. In fact, it's almost the point of science, isn't it, to find out how things work, to find out what the laws are that govern the universe. And way back here in Jeremiah, God says not only that there are indeed laws that govern the universe, but also that he was the one who created them. The fourth example, I think, is one of my favourites. Ecclesiastes 1 verse 7. "All the streams flow into the sea, yet the sea is not full. To the place from which the streams flow, there they return so to flow again." Just consider the knowledge that implies. It implies that the water is not destroyed in the depths of the earth and produced in the heaven, like some people may have thought, but instead water is returned from the sea to the place where the streams flow. It's a great example of the water cycle, isn't it? And in fact, back in Job, we actually get more detail on this process. In chapter 36, verse 27, speaking of God, it says, "He draws the drops of water. They condense into rain from the mist. Then the clouds pour it down. They shower upon mankind." Isn't the accuracy of these verses amazing? We know from the water cycle that water is drawn up from the ocean through evaporation. It forms mist in the sky, which forms clouds, and then they condense into rain, which then showers the earth, flowing back to rivers and back to the sea. It's such a beautiful example of the accuracy of the science in the Bible. And then one last example showing that the Bible and science agree is seen in the sanitary practices given to the nation of Israel as part of the law. And I have three of those just to share. Leviticus 11 verse 28, God says, "The one who carries dead bodies should wash his garments, and he will be unclean until the evening." This displays the understanding of diseases that dead bodies carry. Leviticus 13 verse 1 to 5. This section of verses deals with the identification and management of leprosy. And leprosy is obviously highly contagious, and this was clearly understood in biblical times. And so God imposed a 7-day quarantine period, familiar to us, right, for the person infected with leprosy. I'm sure that every one of us here understands the importance of quarantine in relation to the management of infectious diseases. And then the last example is Deuteronomy 23, verse 12 to 13. And these two verses deal with the management of human excrement, and it reads, "A private place should be designated for use outside the camp, and this is where you should go. A peg should be part of your equipment. When you squat outside, you should dig a hole with it and then cover your excrement." And this again shows an understanding of diseases and sicknesses that human excrement can cause. And it's interesting because maybe the people of Israel, they may not have known the health reasons for some of these laws that God gave to them, but God obviously did, and that's why he obviously gave them the laws, or part of the reason that he gave Israel these laws. And so these examples of the earth being suspended in space, the fact that the earth is round, the accurate description of the water cycle, and specific laws around health and hygiene, they've all been confirmed by science over the ages. So the Bible is not obviously a science textbook, but where science and the Bible intersect, they do actually agree. There is, of course, one subject, though, where science and the Bible disagree, and this is, of course, the subject of evolution. And we're just going to talk about that for the rest of the evening tonight. So Jerry Cohn, an American biologist, describes the theory of evolution as the following. He says, life on Earth evolved gradually, beginning with one primitive species, perhaps a self-replicating molecule that lived more than 3.5 billion years ago. It then branched out over time, throwing off many new and diverse species, and the mechanism for most, but not all, of evolutionary change is natural selection. The first point to make is that evolution is a theory, isn't it? That is why it's called the theory of evolution. No one has been able to prove evolution. And we talked about the scientific method before, didn't we? Consider this now in relation to evolution research. What is the hypothesis? Well, that could be easy. The hypothesis could be, did life evolve from a single molecule? How did life start? Can animals evolve into different animals? But then things get a bit harder, don't they? What about the experiment? How can we design an experiment to test our hypothesis? Can we create life from nothing? Despite all our scientific knowledge, no one has been able to create life from nothing. Maybe we can experiment by observing small genetic changes and mutations around us. But how does this help in answering the question of how does humans come from single molecules? And without experimentation, what have we got to observe and analyse and draw conclusions from? Without being able to undertake experiments, how can we prove evolution? And if we can't prove it, then how can it be considered scientific truth? And this is the real problem, isn't it? When it's taught as scientific truth. I came across this interesting quote by a man named Herman Joseph Muller. He wrote, "There is no sharp line between speculation, hypothesis, theory, principle, and fact, but only a difference along a sliding scale in the degree of probability of the idea. When we say a thing is a fact, then we only mean that its probability is an extremely high one, so high that we are not bothered by doubt about it and are ready to act accordingly. Now, in this use of the term fact, the only proper one, evolution is a fact." And I found this statement quite interesting when I first read it. I thought it was quite absurd. However, there is, I think, a small element of truth to it. If we just consider this as we put a few things on a fact probability line here, if we just consider a few of these facts. If you drop your drink bottle, it is going to fall to the ground. Gravity. Gravity is obviously a fact with a probability of 100%. But if you think about it, if you dropped your bottle in a vacuum, the statement wouldn't actually be true, would it? So maybe gravity is near 100%. I'm wearing a shirt right now. That is also a fact, isn't it? And that is obviously a fact with 100% certainty. What about the statement, if you steal from the shop, you will get caught? Is it a fact? This could be a fact, but might not be. Maybe it's a fact with 60% probability. Maybe 60% of the time people get caught. But we often say it as a fact, don't we? But maybe it's not always true. Humans getting hit by lightning, is that a fact? Well, obviously it is. When I was writing this, actually, it was the day after those two tourists in the Blue Mountains. So last Wednesday, a week and a half ago, when they got hit by lightning in that electrical storm. So again, it is definitely a fact. People definitely get hit by lightning, but that doesn't mean that if we go outside in a lightning storm, we're going to be hit. So it's quite a low probability, but it's still a fact, isn't it? We often hear of a 1 in 100-year flood. The flood doesn't happen every 100 years. And if there hasn't been a 1 in 100-year flood for more than 100 years, does that mean it isn't going to happen? Or isn't a fact? No, it doesn't mean that. It's just got a lower probability. What about this? Is it a fact that you can have a four-headed cow? I've never heard of a four-headed cow. Interestingly, there's been some cases of two-headed cows. The longest one lived 17 months and 15 days in 1991. But a four-headed cow doesn't seem to have ever been around, never happened. There's never been a four-headed cow. So can we call it a fact? And I would suggest that we can't, because it's something that's never happened before. A two-headed cow we can call a fact, because there's been a two-headed cow, but there hasn't been a four-headed cow, so we can't call a four-headed cow a fact. And this displays the flaw in trying to define evolution as a fact. Everything on this scale has happened at some point. And back in 2021, James Taylor did a talk in this hall looking at questions evolution cannot answer. And in his talk, he explained evolution as described by Stephen Hawking in the book Grand Designs. And in Grand Design, Stephen Hawking explains that for humans to have an Earth so perfectly suited to their needs to create life, there must be an infinite number of possibilities of universes, or possible universes, that are configured in all other ways with all other possible laws of nature. So this means that evolution has a probability of 1 out of infinity, which mathematically speaking is undefined and therefore cannot go on our fact line, because evolution is not a scientific fact. It is simply just a theory. So I just want to have a brief look at 5 fatal flaws to evolution. The first one is that life does not arise from non-life. Evolution cannot start from nothing. To be coherent, evolutionists must account for the origin of life, mustn't they? They must explain how life began in the first place. For centuries, people thought that life could just arise by chance, and this false theory was known as spontaneous generation. And Louis Pasteur disproved spontaneous generation in the 19th century, the same year that Darwin's Origin of Species was published. And Louis, in 1958, he did an experiment which is widely considered to have settled the question. In summary, what he did was he heated a liquid designed to grow bacteria in special flasks with swan-like tubes attached, which were to prevent dust particles from carrying bacteria into the broth. He then let them sit to see if bacteria grew. And what he found was that nothing grew in the broths unless the flasks were broken, or if they were tilted, allowing the liquid to come into contact with the necks containing the captured bacteria. And this showed that the living organisms that grew in such broths came from outside as spores on dust, rather than spontaneously generating themselves within the broth. And this was one of the last and most important experiments disproving the theory of spontaneous generation. And he proved what many had suspected for centuries: life cannot arise from inanimate material. And despite many foolhardy attempts to prove otherwise, they've always failed. And the reason is simple: because biological life only arises from other biological life. And this was an obvious problem for evolution, because evolution required the spontaneous generation of life to get started. Whether it happened here on Earth or another planet, evolution cannot happen without it at some point in time. And it's one reason why we know evolution did not happen. The second reason is that DNA is a master plan. Another reason is that DNA, as I said, is a master plan. So DNA is contained in nearly all organisms. They all contain DNA. And it's a master plan for organisms on the planet. So DNA is the hereditary material in humans and almost all other organisms. Nearly every cell in a person's body has the same DNA. The information in DNA is stored as a code made up of 4 chemicals. And humans consist of about 3 billion bases, and more than 99% of those bases are all the same in all people. And so just as a high-rise building cannot be built without blueprints, neither can a human being be constructed without DNA. Building a human requires a blueprint equivalent, which is the DNA. Without DNA, we don't physically exist. Traditionally, evolutionists have argued that natural selection creates the diversity in our DNA. Small natural mutations over millions of years create changes in our genome that ultimately turn single-celled organisms into human. The problem is that mechanism hasn't ever been proven to be true, and in fact what has been proven is the opposite. Dr. Lee Spetner taught information and communication theory at Johns Hopkins University, and he wrote in a book called Refuting Evolution. And he wrote this, he said, "But in all the reading I've done in the life sciences literature, I've never found a mutation that added information. All point mutations that have been studied on the molecular level turn out to reduce the genetic information and not increase it. The neo-Darwinian theory is supposed to explain how the information of life has been built up by evolution, and the essential biological difference between a human and a bacterium is in the information that they contain. All the biological differences follow from that. The human genome has much more information than does the bacterial genome. Information cannot be built by mutations that lose it." And this is a critical dilemma for evolutionists, isn't it? There is no mechanism by which organisms create new information in DNA, and that's a requirement for evolution. Sure, mutations, they do happen, and that's how we get some diseases like cystic fibrosis. But even evolutionists haven't been able to find beneficial consecutive mutations that can turn a simple fruit fly into a different species of fruit fly. Never, and it's a reason why we know that evolution did not happen. The third fatal flaw is that evolution assumes transitional forms. That's a fundamental part of evolution, isn't it? That there are these transitional forms between the different species and organisms. In evolution, transitional forms are the hypothetical creatures that exist as links between various species. And Darwin himself acknowledged the deficiency, but he expected that the fossil records would vindicate him in time. He actually wrote in his book, Origin of Species, "Why then is not every geological formation and every stratum full of such intermediate links? Geology assuredly does not reveal any such fine graduated organic chain, and this, perhaps, is the most obvious and gravest objection which can be urged against my theory." Unfortunately for Darwin's theory, the geological record still hasn't caught up. This is a well-known fact for those who study the fossil record. Some evolutionists have had to admit even so. And one such time there was Colin Patterson, who was a senior paleontologist at the British Museum, and he had to admit this in his book. He said, "I fully agree with your comments on the lack of direct illustration of evolutionary transitions in my book. If I knew of any fossil or living, I would certainly have included them. You suggest that an artist should be used to visualize such transformations, but where would he get the information from? I could not honestly provide it, and if I were to leave it to artistic license, would that not mislead the reader?" Isn't it amazing? A leading evolutionist admits transitional forms are missing from the fossil record. And scientists pride themselves on evidence-based research, but evolutionary theory lacks the essential evidence required in the fossils. And this is obviously a glaring issue with evolution. And as it's alluded to in that quote, we would also expect for there to be transitional forms today, wouldn't we? But alas, we obviously do not have any. The fourth reason that evolution is not true is irreducible complexity. So Michael Behe was the first proponent of the concept, and he wrote this: "An irreducible complex system is one that requires several closely matched parts in order to function, and where removal of one of the components effectively causes the system to cease functioning." So how does irreducible complexity work in real life? Just to give an example first of all, Behe, he presents this humble mousetrap. And I'm sure we've all heard it before. So a mousetrap, it contains 5 interdependent parts which allow it to catch the mouse. You've got the platform and you've got the spring, the hammer, the holding bar and a catch. And each of these 5 components is absolutely essential for the function of the mousetrap. For instance, if you were to remove the catch, you cannot set the trap and it will never catch mice, no matter how long they dance over the contraption. If you remove the spring, then the hammer will just flop uselessly back and forth. Again, it won't catch the mice. And of course, if you remove the holding bar, you will not be able to actually set the trap, and again, you won't be able to catch anything. And there are many examples of irreducible complexity in nature, and in his book, Darwin's Black Box, Behe provides several examples, including the phalangem motor in cells and in blood clotting in humans. And Behe explains the enormous complexity of blood clotting as an example. And I just thought that we could run through this as an example because it's quite interesting. So clotting, it appears to be a simple process. You know, a small cut or scratch in your skin will bleed for a while and then slow down and stop as the visible blood congeals. However, studies over the past 50 years have shown that the visible simplicity is undergirded by a system of remarkable complexity. And in total, there are actually over 20 separate protein parts involved in the vertebrate clotting system. The concerted action of the components results in a formation of a web-like structure at the site of the cut, which traps the red blood cells and stops bleeding. And most of the components of the clotting itself, of the clotting cascade, are involved not in the actual structure of the clot, but instead of the timing of the clot, so that it makes a clot in the appropriate place. Because after all, a clot that forms in the wrong place, such as your heart or your brain, could lead to a heart attack or a stroke. Yet a clot that formed even in the right place but too slowly would obviously do no good either. So the insoluble web-like fingers or fibres of the clot material itself are formed by a protein called fibrin. However, an insoluble web would actually gum up blood flow before a cut or scrape happens. So fibrin exists in the bloodstream initially as a soluble inactive form called fibrinogen. And when the closed circulatory system is breached, fibrinogen is activated by having a piece cut off from one end of 2 of the 3 proteins which comprise it. And this exposes sticky sites on the protein which allow them to aggregate. And because of the shape of the fibrin, the molecules aggregate into long fibres that form the mesh-like work of the clot. And eventually, when the healing is completed, the clot is removed by an enzyme called plasmin. And the enzyme which converts fibrinogen to fibrin is called thrombin. And yet the action of thrombin itself also has to be carefully regulated. If it were not regulated, then thrombin could quickly convert fibrinogen into fibrin, causing massive blood clots and rapid death. And it turns out that thrombin exists in an inactive form as well, and that's called prothrombin, which has to be activated by a component called STIRT factor. But by the same reasoning, the activity of STIRT factor has to be controlled as well. So ultimately, the component that usually begins the cascade is called tissue factor. And so when a cut occurs, blood is exposed to tissue factor, which initiates the clotting cascade. And thus, in the clotting cascade, one component acts upon the other, which acts upon the next, and so forth. And the cascade is irreducibly complex because if a component is removed, the pathway is either immediately turned on or permanently turned off. And it would not do good to think that maybe the pathway started from one end, maybe fibrinogen and then added components, since fibrinogen itself does not do anything good because it's just dissolved in the blood. Nor is it plausible to start even at something like fibrinogen and sort of a non-specific enzyme that might cleave to it, since the clotting would not be regulated and would do much more harm than any good. And Behe here labours the point that blood clotting is nearly mind-bogglingly complex, and to remove even one component in its complexity makes it unusable to the system. So in short, the many instances of irreducible complexity that we find in nature are again proof that evolution could not happen. The last of the 5 reasons, the 5 fatal flaws for evolution theory, is the supposed evidence for evolution itself. So evolution is sometimes simplistically defined as change over time. Organisms change or evolve over time due to natural selection. And the problem with that simplistic definition is that hardly anyone disagrees with it, because organisms, they do change over time. For instance, when one of the most iconic evidences for evolution are Darwin's finches, and these birds that Charles Darwin catalogued on his voyage on the HMS Beagle in 1830, I should say. And Darwin demonstrated differences between the various finches in the Galapagos Islands. Some finches had one kind of beak, which was suitable for their environment, while other finches had another kind of beak, which was suitable for their environment. And Darwin took that example, and others like it, as an example of evolution. And as we said, the problem with that is that it's not. That just shows that there are differences between finches, which are the same species. They're all in the same species. Differences between the finches do nothing to demonstrate the kind of change required in particles to people evolution. The evidence is completely ambiguous. And because it's ambiguous, it's not an example of evolution. The finch example can be explained just as easily from biblical creation. God created the different finches with the different beaks. So, as we come to our conclusion tonight, I hope that we've been able to demonstrate 2 main points. The first point is that the Bible and science, and actual science, does actually agree. The Bible isn't obviously a science textbook, but where science and the Bible do overlap, they do actually agree. And we saw that in a number of examples, didn't we? We saw the example of the water cycle, which I think was probably the greatest really clear proof of that. It's not only amazing due to the age of the Bible, but also it's amazing because of how accurate it was to the actual scientific process that we now know of the water cycle. And then the second point that I've hopefully been able to display tonight is that science and is that evolution is not actually a scientific fact. It is simply just a theory which has managed to rule the scientific world as science continues its quest to find an answer about how the earth and life came about, excluding God from their picture, that is. And as we mentioned, there are some very significant flaws in its theory, the greatest of which is maybe the complete lack of evidence for it. We've shown tonight that the Bible, God's message to man, despite not being a scientific textbook, is 100% accurate in relation to science. And what I propose to you is that it's 100% accurate in relation to many other things as well. For example, the future of the earth and how you can be a part of it. And so I urge you all to come back and listen to other topics here that can tell you about these other subjects where the Bible is 100% accurate as well.
Well, thanks very much, Jimmy. As most of us know here, there is a program of Bible talks which will back that up there, and next week it is baptism requires for salvation. So I can tell you the short answer is yes, but I'm sure Dan Beale will have a much more filled out and elongated answer and tell you exactly why that is. So that's 6 o'clock here next Sunday. So if you'd like to stand, we'll close our evening with prayer and give thanks for the supper. Our loving God, we thank you for this quiet time that we've had now to consider the things of thy creation around us, and we thank you for the blessing that we have of knowing that we live in a world which has been designed by thee, and that our bodies are fearfully and wonderfully made, and we don't need to look for alternative understandings and thinking about these things, but we know that you are in control of all things, and that as soon as we start to question the things of thy word, that then starts to descend into a process of thinking which takes us away from thee. So we pray that you'll help us to not only look at the world around us and the creation around us and be amazed by it, but also to continue to put our faith and our trust in thee, and that knowing that you have a plan to send thy Son back to this earth to set up thy kingdom, when all people on this earth will put away all sorts of other different theories and put their faith and trust in thee, the only true God. So thank you for the time we've had, and thank you for the blessing we have of being able to gather here in peace and safety. And we thank you for the blessing of being able to live in a country which still allows us to discuss and think about these things freely. Please watch over us as we travel home, and thank you for the time that we have now to enjoy the supper which has been prepared. And we ask that you'll be with us in the week ahead and help us to glorify thy name in all things. And it's in Jesus Christ's name we thank you. Amen.